In this example, the equation of in between brackets p minus 2 close bracket x squared plus 8x plus in between brackets p plus 4 close bracket equals 0, where p is a constant, has real roots. For part A, we need to show that p satisfies p squared plus 2p minus 24 bigger than 0. So we start with part A. We have the expression shown, which is p minus 2x squared plus 8x plus p plus 4 close bracket equal 0. So now, since we're told that has no real roots, that means we can use the discriminant, which is b squared minus 4ac, being equated to smaller than 0. So now we need to find our a, b, and c values. So this is our a, and this is our b, and the p plus 4 is our c. So now we use b squared minus 4ac being smaller than 0, and that will be when we use the b squared, so that will be 8 squared minus 4 multiplied by p minus 2 multiplied by p plus 4 being smaller than 0. So now we will try to simplify this expression. So that would be 64 minus 4. And we have, in this scenario, we multiply the brackets by each other. So that will give us p squared plus 2p minus 8 smaller than 0, and then we'll try to simplify this expression even further by multiplying the 4 by the bracket. So then we would have 64 minus 4p squared minus 8p plus 32 being smaller than 0. Then we try to simplify this expression by having the next step would be minus 4p squared by simplifying this expression, and we would have minus 8p, and we would also have plus 96 being smaller than 0. So now we can divide this expression by minus 4, and that would give us in the scenario p squared plus 2p, and also we would have minus 24 being, in the scenario, because they are positive values, it will change the sign from being smaller than 0 to being bigger than 0. And this will be our answer for part A. Now for part B, we need to find the set of possible values of p. So in this scenario, we will start by looking at part B, where we have the expression which is we found in part A, which is p squared plus 2p minus 24, and then we equate it to 0 to find the finding critical values. So that means finding values, we use quadratic formula. So that means we have here A, and we have B, and we have C. So we have, in this scenario, P equal minus B plus minus square root of B squared minus 4AC, and all divided by 2A. So that will give us, in this scenario, P equal minus 2 plus minus root of, in this scenario, 4, and take away 4 multiplied by minus 24, all divided by 2. Then we try to simplify this further, so that will give us p equal minus 2 plus minus root of 100, all divided by 2. So in this scenario, p would be either equal to 4 or p is equal to 6. So these are the two values that we have for p. Now, when we plot this, we will see that it crosses the p, the x-axis at 4, and crosses the x-axis at not minus 6 in this scenario. So we would have, because it's a quadratic equation, we would have the curve coming in this scenario. And since we are looking at positive values, or mainly at a range, the possible set of values. So we're looking at this area, values in this area, and values in this area of the axis. So in this scenario, we would have P be bigger than 4, and we would have P being also in the scenario smaller than -6, and this will be our answer for part B.